Alright, let's correct what we went ahead and messed up horribly. Sorry about that. So just a couple of corrections from the last video. And so I was trying to match to see what the book got for answers, and I realized that I talked myself out of some stuff. So we're just going to complete two of these problems that we did here really quickly. It shouldn't take too long, then we'll go on to the next video. Okay, so here in example 4, and we're going to work backwards 4 to 3. I don't know why I did it this order. But we worked to this point right here. Now, both of these are, we had done this. We had then used the quadratic formula to get to this point right here. And then we said, hey, the inverse cosine of -1 plus root 2, that's some nice number. But the inverse cosine of -1 minus root 2, now that one doesn't work, right? That's not in the domain. And that's where I stopped. So I only received one answer. Now, at this point, I don't know where I got so confused, but here's what happened, right? If we take the inverse cosine right here, I lost my pretty calculator, I'm at home now. But if I take the inverse cosine of this, what I actually get is x equals 1.1437. Okay? So actually if I just take, let's see if my calculator's not as nice, let's see if it even works here. 1 negative plus 2 root inverse cosine, I have it in degrees because I'm silly. Oh man, I hate these old calculators. See, 1.1437, right? I see the old-fashioned calculator right here. So that's just if we do that process right there. Now, I don't know what was wrong with me, but I'm saying this is the only answer that actually works. But when we talk about cosine, right, this says cosine is negative, and there's more than one quadrant where that is true. And so I convinced myself that was the only answer, but we know, in this case, that cosine is positive, because this is a positive number, right? If we take -1 plus root 2, that's actually a positive number, if you think about it. Root 2 minus 1 is just 0.41, okay? So this is a positive number. So cosine is actually positive in this quadrant right here, right? That's our 1.14 radians, okay? But it's also positive right here. So what we need to do in this case, because this is going to be two answers, right? This is saying where is x have this value? And of course there's going to be two answers because there's two quadrants where that's true. So what we're going to do is we're going to use this angle right here as our radian reference angle. And we're also going to use it down here, right? The same angle. So now this one is just 1.14, but to get this guy right here, this whole angle, remember it's actually, let's do this in orange, hopefully that's different enough. It's actually this guy, right? What we need to do is we need to actually do 2 pi minus our 1.14, right? And so my calculator is old-fashioned, so I have to do 2 times pi minus the 1.1437, and that gives me a 5.1395 as a second answer. Okay, and that's of course going to be true, right? There's two quadrants where this happens. And so our two answers, our solution set here, is going to be both these answers. Remember, it's still periodic by its period, so we're going to add 2 pi. N, for n is any integer, same thing here. Okay, that is of course going to happen again. I don't know where I got so lost when I was making that video, but that's what we need to correct here. Okay, the same kind of thing happened on number 3. Okay, so go to number 3. This one we turn into a factoring problem, right? Let me pull this up here. Okay, turn this into a factoring problem, and we factored it as sine of x minus 1 and 3 sine of x plus 2. At least that's what I remember doing. Equals 0, right? That's what we ended up doing. Now, when we're actually doing this, right, we said, hey, this is equal to 0, or this is equal to 0. Then we said this, right, just solving for sine here as well. Now, I don't know how I did so poorly on this, right? We were looking for where is sine of x equal to 1, and I think I showed the unit circle. This is a nice one. I did not have this one. Showed this unit circle, and I was like, look at that. Sine is 1 here, and it's also 1 here. Good job. That's not a 1. That's a negative 1. Okay, so I butchered that. So here, we just get that x is pi over 2. And that's great. Okay? Consistency. But here is where I made the exact same mistake, okay? I said, hey, plug this into your calculator. I get, negative 2/3, 2 divided by 3, negative, inverse sine of that. We trust our calculators here. And I get negative 0.7297. And I said, that's not between 0 and 2 pi, right? We want answers between 0 and 2 pi. And so I went ahead and I took this negative 0.7297 and I added 2 pi to it, because that's going to be in our actual interval, right? And I said this number is 5.55, 3, and then I said 5, I think. And there's our answer. I said, well, there's no other answer. The book says there's another answer, and something's wrong, right? And so I confused myself. But again, of course this is true for more than one quadrant, right? We have this thing right here. Sine is going to be negative both here and here. Okay, and so what we really did is we said, hey, this is our angle. It's negative 0.7297 radians, but the measure of this angle right here is still it's still 0.792 radians, or 797 radians. And so what we need to do is hey, this one right here is actually 2 pi, so all the way around, minus the 0.7927. That one is that. To get this one over here, though, the other quadrant where sine is negative, what we need to do is we need to say, hey, this is going to be pi plus the 0.7297. Because we need to get all the way from pi here over a little bit further. So that answer is 3.8713. Okay? And so our solution set is again going to be pi over 2, no 3 pi over 2 because that's silly, 3.8713, and 5.5535. Now again, the big focus here was the technique and actually getting to that point, right? Once we get to here, we've done most of the work that is actually new to the section, but I somehow just convinced myself of the wrong conclusions here. So take a little bit of time and revisit these conclusions, but those should fix most of the mistakes that I made over the last section. So thanks for watching.